Our second and last example today focuses on a pharmaceutical company, Vitamania, which conducted a survey to establish which age group most frequently takes multivitamins. The ages of these people who are taking multivitamins are recorded in the table below. They first want us to organize this in a stem and leaf plot. So let's see what a stem and leaf plot is. You'll remember from previous years that a stem and leaf plot is a quick way to organize and visualize large amounts of data. So for example, if we have this list of values in our data set, we take the tens position as our stem, so those numbers that I've highlighted there, and the leaves are the numbers in the ones position. And the only challenge here is to put them in order. So in the example that they've highlighted here, 32 becomes stem of 3, and then 2 as the leaf. And then we need to put the leaves in ascending order. Here's another example of stem and leaf, just a different type of formatting. It's quite nice in this example that they give us a key so that we know how to read the stem and leaf diagram. Before I can draw my stem and leaf plot, I need to know what my minimum and maximum values are, because that will show me where I need to start and end the stem and leaf. So you're going to do this with a pencil, but I'm going to go through and I'm going to highlight. This 11 looks like it might be the lowest number, and we're going to quickly scan all the other numbers to confirm that it is the lowest. And then the highest number, we're going to scan through the numbers again. And I see this 79, so maybe that's the highest. You might give it a circle or a tick, but we're going to keep checking. Oh, and I see that 87 is actually the highest number. So I'm going to go through with my eraser and clear that one. So I have my minimum and my maximum values. So I can draw my stem and leaf plot. And in the stem and leaf, I'm going to start with my minimum value, which is 11. And then I know that I go all the way to 87, so my stems have to be the numbers 1 through 8. Then I can start going through systematically through the values and make sure I don't miss any. My first value in the table is 11, so I'm going to strike that out and write the leaf there for 11. The next number to the right is 19. Strike that one out, and I write my leaf as 19. The next number in the table is 21. Strike it out, and I write it on the table. And I keep going like this. And crossing out the numbers to make sure that I don't forget any. Now, notice here in the stem of 30, in 30 to 40 range, I have a problem here. And the problem is that 0 is actually less than all the other numbers. So once I've gone through this entire table, I'm going to have to go back and rewrite my stem and leaf so that it's in ascending order. So this needs to be 0 first, and then all of the other numbers. Once you've completed the stem and leaf, you should have something that looks like this. Now notice, each of these stems has automatically grouped the data into intervals of 10, meaning that this group that I'm circling now in the first row is the group that represents the ages from 10 to 19. The next interval are the ages from 20 to 29. And so on and so forth. So I've managed to group all these different data into intervals of 10. Now the next question that was posed asks us to draw a histogram. But before we can draw the histogram, we need the frequencies. So here we're going to count the number of values, the number of data points within each interval. So let's have a look at that. So class intervals are what we call these groupings. So when we're using grouped data, we group things in what we call class intervals. Now, the book that I got this example from uses the first class interval as the ages from 0 to 9, which we don't have on our stem and leaf plot because we didn't have any people that were those ages in our data set. But it does make sense to include them on the histogram, and you'll see why in a second. The next interval, 10 to 19, and so forth. Then all we need to do is count up the numbers. So 0 to 9, there weren't any, so 0. 10 to 19, there are 5 different data points. From 20 to 29, I have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 people that fall into that interval. And then we have 10 in the next one, and so forth. Okay, so completing that table, you should get the frequencies as we have here in the right-hand column. Don't forget that we always fill in the total number, which allows us to make sure that we've gotten all of our values taken care of. We're not missing anything. We don't have anything extra. I've added in an extra column here in the middle because I want to show you a way that the book likes to write these class intervals. So, as I was talking about before, this is all an example of grouped data. So we're lumping together the data points into different groupings. And in this example, I'm not really interested in the number of 25-year-olds that are taking multivitamins. But if I know the number of 20 to 29-year-olds, that might give me an indication of what's happening. And similarly, I'm not interested in just the 61-year-olds because that's a relatively narrow group. But 60 to 69-year-olds gives me a little bit more of a range, so I can see some nuances to the data. So again, looking at this middle section, I could call this class interval 0 to 9. That would be easier. But what's commonly done is to use this notation instead, where we use our inequalities. So let's look at this. We already know this is the group that has the ages from 0 to 9 years old, including 9. Now this format says the same thing. So it says that 0 can be equal to x. X is a data value that falls into this category. And that 10 is greater than x, or x is less than 10. X is less than 10, which means that x cannot be equal to 10. Look at the next grouping. We said that the next grouping includes 10. So that means that 10 can be equal to the value in this row. So this is just another way of showing the interval, and it's just a little bit more mathematical. The book uses it, and I want you to be familiar with it. Here are all the rest in that same format. So let's draw our histogram. So here's our histogram for this problem, and we can see immediately that there are a few things that pop out to us that didn't really come out to us when all the data was just listed on a big table. A histogram we use when we have continuous data, and often used when we have group data. In a histogram, we know that the bars touch each other, but maybe you've never thought about why they touch each other. Well, if we look at this value that's separating these two intervals, this interval are the numbers from 10 to 19, and this interval are the numbers from 20 to 29. So there's no real gap in between these, so the bars can touch each other. That's what we mean by it being continuous. The data continues on with no gap in between. We can use this data now to answer questions 3 and 4 that were posed as part of this problem. So question 3, what percentage of those who take multivitamins are below age 40? So below age 40, that includes this interval, this one, and this one. So we can either look at our frequency table or we can just read off the graph. We have 5 in that group, 8 people in that group, and 10 in that group. So in total, we have 23 people who are below the age of 40. We take that out of our total, which is 66, multiply by 100 because it's a percent, and that gives us 34,85. I've rounded off to 2 decimal places there. So we can see that the majority, more than 65% of people, are over 40 who are using multivitamins, which might be interested if you're somebody who is marketing multivitamins. You might focus on older people and not worry about the younger people. Which age group, this is number 4, which age group most uses multivitamins regularly? This is obviously going to be the one that's the biggest. So this age group has to be the 50 to 60-year-olds, or technically 50 to 59-year-olds. And there are 18 people in that group. Again, if you're a marketing manager, you might simply focus your attention on that group because they're the ones who are most using multivitamins. So those are the types of graphs and plots that we're mostly going to focus on in grade 10. But you do need to remember the other types that you learned in previous years. The first type is called a back-to-back stem and leaf plot, and there's a question like this in your homework that you have to do tonight. A back-to-back stem and leaf plot is useful when we're organizing and comparing two different but related data sets. So in this case, we've got brand A is a certain cell phone, brand B is a certain cell phone, and different people had different experiences of battery time. So that's what's shown in this back-to-back stem and leaf plot. The two columns on the right-hand side, we read just like a normal stem and leaf. So the 5 and 6 we read as 56. But it becomes interesting when we're looking at the left two columns, so the stem and the leaf on this side. If we look at this number, we read the stem first, just like before. So this number is 61. We read it backwards. If we look at this number, 3 and 0, we read it backwards, so this is the number 30. Not too difficult. Recall that we can also use pie charts to display and represent data. Pie charts are useful when you wish to see how much a certain category takes up. So for example, in this survey results of favorite sports, we can immediately see that the biggest preferred sport is football. But that wouldn't necessarily jump out at us if we were looking on a table. It's customary to label your pie charts with the category and with the percentage. We don't always do that, but it's good practice. And if you need a refresher on how to draw a pie chart, here's something that you can look at in your notes. The last plot for us to discuss is one that you learned about in grade 9, and it's called a scatter plot. A scatter plot is a way of seeing if there's a relationship between two distinct sets of data. And that relationship we call a correlation. So in this graph, I'm showing the amount of chocolate consumed per person in a population. So this is organized by country. And the Nobel laureates. And you know that the Nobel Prize is a very prestigious prize that's awarded to people who are at the top of their careers. So looking at this graph, it looks like there may be a relationship. Maybe chocolate is causing people to win Nobel Prizes. But hopefully you're thinking that doesn't really make sense, because there's lots of other factors that go into it. There's the education of the people in the country, there's the amount of money that goes into research and academia and those types of people who would win a Nobel Prize. So remember that just because there's a relationship, just because there's a correlation, does not always mean that it's causation, does not always mean, in this case, that chocolate causes people to win Nobel Prizes. Maybe it's a small aspect of it, but I don't think that we can attribute it solely to that. For homework, you have page 221 to 223, exercise 1, A, B, C, F, and G. Until next time.